Okay. Hello, everyone. And Nick, thank you for talking to Jeff and getting that all worked out. We very much appreciate it. Um, it's good to be here. My name is Adam Keller. I am a developer advocate on the containers team, and we are hosting Containers on the Couch, and we're going through the ECS workshop. This is day 3 of that, and next to me is Brent. You want to give a shout out and hello?
Of course, I'm Brent Langston. I'm a developer advocate on the containers team, and I'm really looking forward to learning about ECS today.
Perfect. Okay, so at a high level, my usual, I always use that term, at a high level. I got to get better about that. Um, so just kind of recapping what we did over the past couple of days. This is ECS Workshop. This is publicly available. If you're at your computer right now, which I assume you are unless you're watching Twitch from your phone, um, you can access ECS Workshop from ecsworkshop.com and go through this workshop at your own pace whenever you want. Um, but what we did over the past couple of days was, first of all, the idea of this workshop is to deploy a 3-tier polyglot microservice application. Um, on day 1, we built out a platform, and that platform consisted of an ECS cluster. It consisted of all the networking components we needed for our environment to run, um, as well as basically anything that we needed from a low-level infrastructure point of view. From there,
Yeah, and we
good.
used CDK for that, right?
We did, yes, and we did this all using the CDK. Thank you, Brent. Um, and for those that aren't familiar with the CDK, this is the AWS Cloud Development Kit. It's a way to declare your infrastructure truly as code. So if you're familiar with CloudFormation templates are built with either JSON or YAML as the format. Whereas with the CDK, we are building our environments using Python. So our actual environment is built using Python code. And this is just an example of what some of that code looks like. Whereas, we had gone over this the past couple of days, but just a quick refresher. I have 3 lines of code here that's creating a VPC, a virtual private cloud. And within those 3 lines of code, it's creating many lines of CloudFormation that the CDK will help deploy on our behalf. So it's a,
You
yeah,
know, sorry, one
good.
other, I think, interesting thing to point out that I forgot to point out even the day that we did this. The workshop purposefully, is built using 3 different languages: Ruby, Node, and Crystalline. And then when you added CDK to it, you brought in a 4th language, Python. So it's really cool to see how like all this stuff works together. The CDK code actually lives in the same repo as the apps that we end up deploying, and yet we're deploying a Ruby app, but we're using Python CDK to do it. So I think that's really cool, and it just shows that all this stuff can coexist together, but at the same time, you can still pick the best tool for the job. And we're not necessarily saying Python is the best at CDK, but it's what we wanted to use because it's what we were the most familiar with. So it was our best tool for the job. So anyway,
Yeah.
I thought that was kind of cool as I was looking back on things.
Yeah, that is cool. Great point. And CDK, by the way, if you're a Node enthusiast, TypeScript enthusiast, you can use those languages as well as .NET uh, and I believe Java support. I just don't know if Java's GA yet. But anyway, so yeah, that's a great point. So we decided to use Python because, as I've said, I really like Python, and this is just a thing I can't get over. So um,
We even have another person in the chat that agrees with us. Sorry, Retep Pi. His pi is in his name.
see, there you go. I felt like that. And
Yeah.
by the way, so everyone knows, we did not plant that person in the audience. They are a real audience member. So, so anyways, um, but yeah, so as we were saying, we built out our platform and we kind of looked, we talked about this being from, when you break up your service teams, it's very common to have a platform team that's responsible for, building the environments in the cloud and building them to a standard that the organization, the company sees as their best standard, their best practice. So that's what we've essentially done with this platform. And then what we've done is we've deployed three microservice applications: a front end, Ruby on Rails, a Node.js backend, as well as a Crystal Lang backend, which all communicate through service discovery, which is through AWS Cloud Map. So this is the application that we actually deployed. So you can see a cool little point to talk about here is yesterday with our front end, we deployed the front end service. We used an open source tool called Siege, and we started to send a lot of load to our front end service. And what we did was, prior to sending that load, we enabled service auto scaling, and we based it off of CPU utilization. And our target tracking metric was 50% CPU utilization. And what we saw was, and actually I'll go to a graph to showcase this. Brent helped me find this earlier, but this is essentially the load balancer, the target group. And you can see that once we added the load, you can see that it started to step up pretty quickly to our max threshold, which was 10 tasks of that service, 10 instances of that service running to meet the demand. And once we stopped sending the load, you can see it gradually scaled in. And one thing you mentioned, Brent, yesterday that I think is really important to talk about is the scaling out may be a little more aggressive, so you can see we jumped from 1 to 2, 2 to 4, 4 to 7, and then ultimately 7 to 10. But when it scales back down, we're much more conservative in those steps. So you can see that being reflected here.
Exactly. Scaling in is one of the areas where you should be conservative, because one, you don't know if your traffic is spiky, if you might end up having to scale back out. So you want to be a little bit hesitant to scale in. And then two, as you start to terminate services, any load that would have been directed to those would get shifted to the remaining services. So you want to make sure that that those are going to be able to handle that load correctly without going over. So stair stepping back down, a little bit more slowly, a little bit in a little bit smaller chunks is definitely the preference here. But if you have a spike coming in, like we see on the left side of that graph, ramp up as fast as possible and as with as fewer bigger steps as possible is definitely the way to handle that kind of traffic.
Yeah, and you can just see here the scaling event to 2 was at 12:46 p.m., jumped to 4, 12:48, so that was 2 minutes, and then 2 minutes later it jumped to 7, and then the same thing. So pretty aggressive to meet that target that we desired, that we set in our auto scaling, and then as you can see, a slower, step down process. So that was cool, and so we demoed that yesterday. And this is just another example of a Cloudwatch metric. And by the way, this speaks to the native integrations with ECS has with the AWS platform in general, that Cloudwatch integrations are just out of the box. So CPU utilization, memory utilization, that just comes out of the box when you deploy an ECS service. So I was able to just take that metric and use that as our scaling metric.
Yeah. And let's not take for granted the fact that we aren't having to run, a time series database, a graphing solution, something that that aggregates metrics and sends them to our time series database. Like, these are all things that we don't have to figure out how to manage, and we don't have to figure out how to deploy and all that stuff. It's just built in because we're using ECS as our platform. And it has all of these native integrations with the rest of AWS. It's really cool.
Yeah.
We do have a question from Sporadic in the chat. He's writing some CDK right now. and he says, "Can I quickly see how that auto scaling config looks in CDK?"
Oh
And I
yeah,
know we're recapping, but let's just continue the recap for another 30 seconds, and let's see if we can pull that up.
absolutely. Yeah. So let me go to the. I'm in the front end service. Okay, let me close this out, and hopefully everyone can see my screen. It's or can see the font pretty well. It's super zoomed in. So here is an example of, okay, so we use the high level construct. I've talked about constructs yesterday. CDK, really quick description. A construct is essentially a way to bundle in best practices, as well as bundle in a way to build one or multiple resources with one command, one call, rather than having to do it multiple times in multiple different areas. So we're using the application load balance Fargate service construct, which creates an application load balancer, connects my service to the load balancer, does all those amazing things for me. And once I create that object, if we scroll down here, you can see, and by the way, this is available on GitHub, which we, at ECS Workshop, really quick, I will show you. If you scroll down, you can see the front end repo. That's where you're going to find this code. So going back, I simply start with two things. So I take that service from my construct that I use to create my auto scale. I'm sorry, my load balance service. I'm setting the auto scale task count method. So that's the first step. So I just set my minimum maximum capacity, and then I determine out of the pre-built. So there are pre-built metrics that I can use, or if I have a custom metric, I could use that as well. I could scale on a custom metric, but in this example, I just I just used the scale on CPU utilization method that's available, and that's how I'm able to deploy service auto scaling. So all that complex, figuring out and logic that goes into figuring out service auto scaling was defined here in 10 lines of code, including a comment. So hopefully
Yeah,
that
that's awesome.
answers the question. But
CDK is terrific.
yeah, so it really just it's that benefit of letting the people who know how to do this best, let's let them continue to do that. And I just want to deploy on the using the best practices, and knowing what those best practices are, just being pre-baked, built into the tool I'm using. So I really love that about CDK. So, okay. So that was the auto scaling. And then, of course, like I said, we deployed our backend services. So this is the application we deploy. The front end gives us this nice graphic, which shows what it's talking to, what availability zone it lives in. So when this was scaling up yesterday, we saw the front end uh, switching between different availability zones. But then as it scaled back down, it's just one instance now. And you can see it's not moving. So that's pretty much a recap from yesterday. And again, we have our platform now. We have our ECS services running. So let's go back. We can go to our cluster. We've got a cluster. We have our three services running. Everything's looking really great. But now I want to get a little more granular with the metrics. I want to get a little more granular with the cluster level metrics. How do we do that? So that leads us to the next section of the workshop, which is Cloudwatch Container Insights. So again, talking about native integrations, um, and full disclosure, I am in by no means an expert on container insights, or CloudWatch Container Insights, but as I was talking with Brent earlier, that's the beauty of CloudWatch Container Insights, is I don't have to really be an expert, and we'll see why in a moment. But essentially, Container Insights is a way for us to collect and summarize metrics from our applications, our services running in ECS, and we can see cluster level metrics, service level metrics, as well as um, task level metrics. So we can get granular down to the task. And remember, a task is an instantiation of a container definition that's running one or multiple containers. Um, yep. So let's get to it. Okay. So I have my Cloud9 instance up. now I want to get in there and I want to actually deploy and enable container insights. So when we created the cluster, we did not enable container insights. That's something that we have the ability to enable or not enable when we build the cluster. So now I'm going to move this back here. We're just going to move this here. And what we're going to do is we're just going to grab a couple of metrics that we need, or a couple of parameters that we need. We need to know our cluster name, and we need that to enable container insights. So what I did was with the AWS CLI, I just used, I was able to grab the cluster ARN by doing just a little JQ from the response, and then I was able to describe the clusters and get that cluster specific cluster name that I needed. And now what we're going to do,
so
go ahead.
This command we're doing is a programmatic way to do it, because we want to make sure that we get the right cluster and everything. But if you're in like a super simple environment, you might only have one cluster, and you can just type the command in directly using whatever cluster name you happen to have. So it looks like it might be a complex command. It looks complicated, but it's actually pretty simple.
Well said. Yeah, exactly. So, okay, so now we've got our cluster name, and now I want to issue a command to enable container insights, which again, I can enable this by default when I create a cluster, but in this instance we did not, so now we're enabling it later. So what we've done is through the AWS CLI, we changed the cluster settings to enable container insights, and you can see our response is container insights enabled. We're good. So now we're going to move on. Now, one step here is to enable instance level insights. And one thing you'll find is we don't have any EC2 instances here, but I'm going to just deploy this anyways. But essentially what this is doing is this is going to create, it's going to deploy a CloudFormation template that is basically deploying an ECS service as a daemon set, which a daemon set is strategy to essentially ensure that this service runs once on every EC2 instance in my cluster. So again, we don't have any, but EC2 instances running because we're using Fargate. But if we did, this would install a Cloudwatch agent on that server to enable the shipment of metrics.
So Adam, interrupt real quick just
Please.
to answer some of the chat questions. So we had some questions. TrueSpec123 wants to know, how is CDK support compared to CloudFormation and Terraform? He thinks it looks really good. He or she thinks it looks really good, but have teams not adopt it due to lack of support? And then there was some discussion from Sporadic, has a great follow-up to that. But basically, in my talks with the teams, the CDK team is trying very hard to have a release be available every single time there is an enhancement to CloudFormation. So there might be, as Sporadic mentioned, there might be a few days where there's something in CloudFormation, but by a week's time or so, you'll probably see that that feature picked up in CDK as well. So I definitely would encourage you to check out CDK. Definitely experiment with it and see if it fits in your workflow, because what it brings to the table is a lot of baked-in knowledge and experience and understanding of how to do things and how best to do things at AWS. And the converse would be writing at least 10x more code and possibly not doing things as effectively or not linking things together as effectively as you could. So, and then I don't know how to say this, Crangents wants to know, the software that we use to build a platform that we mentioned, is it free and open source? The CDK definitely is free and open source. You can contribute to it directly. And in fact, we even have a coworker that contributes to it and helps write the construct, the ALB or the load balance Fargate service. So that's really cool. You can also then take it and include your own, if you want to build your own constructs that are good for your own company, and you can supplement what's available in the public. You can supplement with your own stuff. So that's a pretty amazing feature.
Yep. And to add to what you said earlier, so CDK is of course limited because CDK compiles into CloudFormation templates and deploys CloudFormation. So of course the CDK is limited by whatever's available in CloudFormation. Um, so there's the idea of these higher level constructs with CDK, but there's also, if a resource is available in CloudFormation, you can deploy it with CDK using the low level CFN resource. So I could actually, if something was released in CloudFormation, but it's not available, but there's not like a high level construct for it, there's a way to get to the low level, use CDK to build low level CloudFormation constructs. So you can actually do that. Um, but where the real value of CDK comes in, that's a great way to solve the, hey, a new feature was released, I want to get it into my code, but there's not a high level construct available for it yet. No problem. You can use the low level CFN construct to get what you need built. But as we iterate on the CDK, eventually there will be a construct available that makes it easier. For example, when you want to sync resources together, you want to be able to grant permissions from one resource to another. This is where CDK is really powerful. And once you get those constructs built, it becomes night and day to sync those resources together. And an example would be if you have a service that needs access to an S3 bucket, the S3 construct has a grant read or a grant write method that you can simply call. You pass in the resource that you want to grant that access to, and you're done. Whereas I, prior to working at AWS, everything I built was on AWS. I've just been doing it for a few years now, and 7+ years actually. And what I'll say is, writing IAM policies and trying to manage all that, it's tough.
Careful.
Right. It's tough. Thank you, Brent. But it could be challenging, right? Because there's so much you have to consider, and there's a lot that goes into it. So the nice thing is, I just let the CDK help me by doing that for me, And of course, if I need to create IAM policies and resources, I can on my own, but I prefer to let CDK do it. So
100%.
yeah, and it's, as Brent said, just depending on what, evaluate it, see what works best for your team, your organization. But yeah, I love the CDK. It's so much fun. Prior to using this, just because I sometimes struggle to read large, JSON files or large YAML files, I used Troposphere, which was an open source project that would generate CloudFormation for you, but I still had to build all the underlying components. So anyways, I'm going to stop there because I feel like I could keep talking about it. Okay, so going back, so we've enabled container insights on our cluster. It takes a few minutes to start generating metrics. So Brent, I'm going to steal your line. So we had a pie in the oven. Now we're going to pull it out here. We had one already pre-made where I have another cluster that I enabled container insights on. So because it can take some time to get those metrics into container insights. So as you can see here, I can scroll. By the way, this is supported with EKS as well, but it's a centralized place to view all pretty much the metrics that are tied to my ECS clusters, ECS instances. So remember, ECS you can have Fargate. You can run a Fargate task, which is no management of EC2 instances for you, the user, or you can deploy your service or your task to an EC2 backed instance in the cluster, but I don't have any in this example. But we can go down to the clusters. We can drill down by multiple clusters. I can aggregate data across multiple clusters if I wanted to see. I could see task count, service count, kind of all these just high-level metrics. It's really nice to have the ability to see at a cluster level, what's my total CPU utilization? And this is across all services and tasks running in that cluster. But then also I can drill down to the service level. So one thing I'll speak to is we've heard customers talk about prior to Container Insights is the ability to have that granular access from a metrics perspective into a task to see. I want to know which, I may have 10 tasks running, but only one of them is spiking on CPU. And it used to be tough to figure out which service that was. To find out which, you'd have to go to Cloudwatch and aggregate all the metrics. Well, Container Insights handles that for you. So you can see now I have this drilled down by services, which gives me a high level of each service. I can see how services are doing from a utilization perspective. But then a step deeper is I can actually drill down into the tasks. So now you can see here's all my tasks running. Okay, what's the performance like on a per task basis? And I can filter on tasks. I could just see if I wanted to look at the front end, I could simply filter on that and see all of the tasks running for the front end. This is a bad example because I only have one task running. I think Node.js is running across, I think we have 3 tasks running. Did I mess up? Let's go Node.js. Okay. Okay, there we go. There we go. Okay. Anyways, and I can see all my tasks down here running for that particular service. So, anyways, not a 400 level expert on Container Insights, but I will say there's so much value that I can derive out of this this data that I can use to take action on, or ideally we have auto remediation in place. But when things aren't working as I expect, I have a central place where I can go look and actually see what's happening in real time.
Exactly. And again, to turn it on, it was a simple command on the command line. It was so easy. It was the equivalent of checking a box. So it can't be easier. It's just amazing that you get this kind of functionality without having to run all of those services that you normally need to run.
Exactly. I mean, it was the point of you don't have to think about a time series database. You don't have to think about where you're storing all these metrics. CloudWatch just takes care of that. It's really nice.
Yep.
And
Yep.
one thing, so if we had X-ray enabled, X-ray is our tracing and a way to see your application tracing from one service to the next. I could drill down into a task and actually see the X-ray traces for that task. I could also go to the application logs, which it will redirect me to the log stream that's running for that particular service. I can query it, check out what's going on, and so on. So it's that central place to have that insight, and then it can take me to where I need to go if I need to drill down deeper into any of the services.
Awesome. What does this look like if you were to put a service like under load and see, a whole bunch of traffic hitting it?
So let's do that. So first I want to go back and see so you can see we have a very small data point here because we just started aggregating this data into our cluster. But, maybe it would be better in this environment to send some load. I think that's what I'm going to do.
Okay.
And what I will do here is I'm going to we used this previously to throw load at the front end. I'm going to use Siege to send quite a bit of load to the cluster. And the idea here is in Container Insights, we should be able to see what that looks like from an aggregated view. So let's do that. Okay, so let's first confirm I have it installed. I do. So I'm halfway there. And now I'm going to grab the ALB URL. So again, as Brent said, this is I'm running a command that looks pretty complex and complicated. But the idea here is I just want to programmatically pull down the application load balancer URL, so we can start sending the request to that URL. So let's just make sure that it pulled down the URL, which it did. And if I were to go here, you can see it's running. Okay, so now what we're going to do is we're going to send some traffic, and we're going to go nuts here. Introduce some chaos. So this is going to take
Nice.
a few minutes, and I almost
While
think.
we have a few
Yeah,
minutes,
go ahead. Questions,
sorry,
concerns? Let's do it.
sorry, just jumping in. We have a question in the chat from Liquid Juice. Do I need to install something on worker nodes to obtain metrics from EKS? And I'll start by saying short answer, yes. But longer answer, there's a daemon set that you can install, and this is the case for both ECS and for EKS. When you have EC2 instances as your data plane, then yes, you install a daemon set, and that will help gather and send metrics for you. Even longer answer and a slight plug though is you're here today, watching us do ECS workshop, containers from the couch. Come back next week and we'll be doing the same type of workshop, but using EKS. We'll be going through EKS workshop. So, absolutely come back if gathering metrics and doing Cloudwatch Container Insights, is important, and we'll make sure that we cover that as well. So,
absolutely.
And yes, to John Exum 77, the times will be the same. So yeah, absolutely, come back and join us.
Yes, please do. So I just started to push some load here, so we're going to give it a couple minutes, but what we're going to see is obviously our front end is going to start spiking in utilization here. So that takes a few minutes to start to show up. But you can see here in the dashboard or in the workshop, we walk you through it. So it's really nice if you're doing this on your own, if you're doing this in a workshop setting, obviously. So if you're doing that, what you'll see is it walks you through all the steps. It tells you where to look in the console. And what we should see in the next few minutes is you'll notice we're going to see a spike in our services. So this is showing you a spike in the ECS instances. So if we had EC2 instances in our cluster, we'd start to see this spike from the cluster level. And then, but you can see here from a service level, our front end service spiked up, and that's where we're seeing that influx in traffic. So,
Exactly.
yeah, so this takes a few minutes. I almost feel like at this point, maybe we should pivot and maybe look at one of these other sections of the workshop, and then we can come back and just see how things are going.
That's a good idea. I think while you're getting ready for that, one other question popped up in the chat. Is the daemon you mentioned, is that the X-ray daemon? There is an X-ray daemon, and certainly if you want to gather X-ray metrics, you would use that. But there's separate from that, there is a CloudWatch Container Insights daemon that you can install as a daemon set that you can install as well. So two different daemon sets for the two different purposes.
Yeah.